We're in business.
Okay. Good. Should be good.
All right. Okay, so for question 1, all we had to do was reduce the following. And so for A, we had negative 54 over 36. B, we had 51 over 34. But the process is still the same. Just want to reduce it to its lowest terms. So for this A, negative 54 over 36, can anyone think of something that is a factor of both 54 and 36? Yep. 3? Sorry, did you say 3 or 2?
Yeah.
3? All right. Yeah, we can divide these each by 3. That sounds good. So 54 divided by 3, what does that get us? That'll be 18. And then 36 divided by 3 gets us 12. So now we've got 18 over 12. Can we reduce this any further? Yeah, see some nods? What's a common factor of both 18 and 12? Yeah? 2? Sure. Divide each by 2. Okay, so then we get 9 over 6. We done yet? Not quite? Yep.
There's 3.
Yeah, exactly. You could also factor out 3. And so, in the end, then, we'll get 3, sorry, these should be negative. Negative 3 over 2. So make sure it's the same. If it starts off as being negative, it should end up negative. You shouldn't be able to change it by reducing it. That would change the actual value. So yeah, that'll be our final answer, is negative 3 over 2. How about for B? B is a bit trickier, because unfortunately, with A, we did this a nice strategy of just dividing it by 3 and then by 2, and then we kept finding 3s and 2s and 6s in there. So that was okay. We never had to do anything super challenging. Unfortunately for this one, there's going to be a very particular factor that we need. So what is something that is a factor of both 51 and 34? Yep.
17.
Exactly. So we can actually divide these each by 17. So not as simple as doing it by 2s and 3s, but still gets you the right way. So if we divide 51 by 17, that gets us 3. And 34 by 17, that gets us 2. So in the end, we have 3 over 2, or 3 halves. And then that's fully reduced. Again, if you have 2 prime numbers, you know that you're done. Or in fact, if you have any prime number in the numerator or in the denominator, you're done. You can't really reduce that at all, because the only factors you're going to get are 1 or itself. Okay, so for number 2, we've got a number line here, and we want to match these points to the letters that correspond with them. So first things first, what I would do is I would divide these up into the positive ones and the negative ones, because we know that anything to the left of this 0 is going to have to be negative, and anything to the right of this 0 is going to have to be positive. So we know that the positive ones are going to have to be either A or D, and the negative ones are going to have to be either B or C. So we can let's think about this one first, negative 8 over 4. What is that equal to? Can we reduce negative 8 over 4 at all? Yep.
It's equal to 2 over 1.
Exactly. So if we divide the numerator and the denominator by 4, we get negative 2 over 1, which is just the same as saying negative 2. And we do have a number, negative 2, that has a letter associated. So that means that this is going to have to be B. Negative 8 over 4 is our point B. And that means, if you just use the process of elimination there, that means that negative 1 over 3 is going to have to be C. But let's just make sure that makes sense. So if we look at point C, which should be about 1/3 of negative 1, and it is. So that's good. So negative 1 divided by 3, that brings us closer to the 0 and to our point C. Now for A and D, we've got two fractions here, 11 over 6 and 7 over 6. We know that 7 over 6 is going to have to be less than 11 over 6. So this becomes pretty easy. This one A is less than this one D, so that means that 7 over 6 is going to have to be A, and 11 over 6 is going to have to be D. So overall, we've got B, then D, then A, then C. Any questions about that one? Okay, great. All right. For number 3, we need to I guess that means convert the following to improper fractions. So first off, we've got 3 2/3. So can anyone tell me what 3 2/3 is in improper fraction form? Yeah? 11 over 3, exactly. So we can think of that as being 3 times 3. So we have our leading number and our denominator. We multiply them together and then add on what we have in the numerator, divide by the denominator. And then that gets us 9 plus 2 over 3, or just 11 over 3. All right. For -1 and 1/5, it's going to work a little bit differently. Well, not really, but we just need to be careful about one thing. We just want to make sure that we apply the negative at the very end after we figured out what the improper fraction is. So we can think about this as negative, and then we do the same process. So 1 times 5 plus 1 plus our numerator of 1 divided by 5. And so that's going to be equal to -6 over 5. Okay? So again, it's important that you don't do -1 times 5 in the numerator and then add 1, because that'll get you the wrong answer. So I like to think about it with the negative very much separate and then put it back in at the end. Any questions about that? Good stuff. Okay, for number 4, we need to compare the following fractions using greater than or less than symbols. So the easiest way to do this, or maybe not the easiest way, but the way that will for sure get you the right answer, is to put them in terms of common denominators. Because, I don't know, yeah, you can probably look at 1/5 and 1/7 and think, okay, 1/7 is going to have to be smaller because you're dividing 1 by a bigger number. So you can just use logic there and figure that that's true. Or you can put it into common denominator form. Because if you look at this one, 4 over 7 and 5 over 9, it's maybe not as obvious which one's bigger just by inspection. So the best way to do it is to always put it into common denominator form. So let's just confirm that this is true, that 1 over 5 is greater than 1 over 7. And that's by doing common denominators. So what's the common denominator between 5 and 7? Yep. 35, yeah, just 5 times 7. So that means that we've got 7 over 35. So 5 times 7 gets you 35, so we need to put 7 on the numerator. And 1 over 7 is equal to 5 over 35. So now we can do a direct comparison, now that we've got them in the same denominator. And we confirm that 1 over 5 is greater than 1 over 7, because 7 over 35 is obviously greater than 5 over 35. Okay. Now for this one, like I said, we're going to have to put it into a common denominator. What's the common denominator between 7 and 9? Let's see, anyone else? No? Okay. Yep.
63.
63, exactly. So just 7 times 9 gets you 63. So we can use 63 as a common denominator. Good stuff. So 4 times 9, that gets you 36 over 63. And then 5 over 9. So that needs to be multiplied by 7. So we've got 35 over 63. And because of that, because 36 over 63 is greater than 35 over 63, that means that 4 over 7 is greater than 5 over 9. It's very close, and it's very hard to do this by inspection, but it is greater. Any questions about that? Okay. Up next, we've got, this is kind of cut off, but that's 6 over 7. Yeah. Okay, so we need to determine a fraction between 5 over 7 and 6 over 7. So can anyone think of something that's in between 5 over 7 and 6 over 7? And is a fraction? Yep. 11 fourteenths, yeah. So what you can do is you can multiply the numerators and the denominators by 2 to essentially this is like our number line example where we had intervals going up in sevenths. You can consider it as intervals going up in sevenths. And then if we divide it by 2, if we multiply the numerator and the denominator by 2, we can measure in fourteenths now. So this would be equal to 10 fourteenths. This would be 12 fourteenths. And then in between, we'd have 11 fourteenths. So that's great. So that means that 11 over 14 is in between those fractions. The way we're going to express that is we're going to say that 5 over 7 is less than 11 over 14 is less than 6 over 7. So 11 over 14 is our answer. Any questions? Okay. All right, and now we've got some evaluations that have to do with multiplication, addition, all that good stuff with fractions. So first off, we've got 3 over 8 times negative 6 over 7. So with this one, because we're multiplying, we're not going to need to find a common denominator. We could if we really wanted to, but we don't have to. So all we need to do is just multiply the numerators and the denominators. So that gets us, so 3 times negative 6 is going to be negative 18. And then 7 times 8 is going to be 56. So that gives us negative 18 over 56. Now, we've got two even numbers here. 18 and 56 are both even numbers. So that tells us right away it's not in a fully reduced form. So if we divide each by 2, we get negative 9. And then 56 divided by 2 is 28. Negative 9 over 28. And that's in reduced form. You can't really go any further than that. Okay. For B, we've got a situation where we have a mixed number and a fraction that we need to divide. So we're going to have to convert it to an improper fraction first, but otherwise it's going to be the same. So I won't go through this in detail, but that's going to be equal to negative 4 over 3. And we need to multiply by the reciprocal here. Remember, division is the same as multiplying by the reciprocal. So instead of dividing 5 over 6, we're going to be multiplying 6 over 5. And then we can just do the same stuff again. We can just do multiply the numerators, multiply the denominators. So that's going to be negative 24 over 15. And this is not in reduced form because I can think of one factor that they share, and that's 3. So if we divide each by 3, you get your final answer, which is 24 divided by 3 is 8, so negative 8 over 5. That'll be your final answer. Any questions about these two? All right. And for C, we've got addition, or in this case, you can consider it as addition or subtraction, whichever makes more sense to you. But either way, we need to find a common denominator between 3 and 7. So that's going to be 21. They're both prime numbers, so the lowest common denominator is going to be 21, which is just 3 times 7. So that's going to get you 7 over 21 plus negative, and then this one we need to multiply by 3, so 15 over 21. Okay, and then if we're adding, we just do 7 plus negative 15. You can also think of it as a subtraction, just 7 minus 15. Either way, you're going to get negative 8 as your numerator, and it's going to be negative 8 over 21. And that's going to be fully reduced. Okay. And then lastly, we've got D. So D is going to be a bit more complicated. It involves, some order of operations. And this is something that we struggled with a little bit on the last quiz, the order of operations plus fraction stuff. So I'm going to make sure that I go through this slowly. So in this case, we've got a multiplication, a subtraction, and a division. So by BEDMAS, we're going to want to be doing our multiplication and our divisions first. So I'm just going to put them in parentheses just to make that pretty clear. So we've got 1 over 2 times 6 over 5. Okay, that's one operation we're doing. And then we're going to be adding that to whatever the result of this is, where it's negative 4 over 7 divided by negative 2 over 3. And right away, I'm going to switch the division into a multiplication. So I'm going to turn that into times negative 3 over 2. Okay, so just the reciprocal, multiply by the reciprocal, and then we can carry these out. So now we've got 6 over 10 plus, and then we've got two negative numbers multiplying, so we're going to end up with a positive here. It's going to be 12 over 14. Okay? So now we need to find the common denominator here because we're going into an addition. So a common denominator might be 70 here because 10 times 7 is 70, 14 times 5 is 70. So that gives us 7 times 6, which is 42 over 70. And then 12 times 5 is going to be 60 over 70. And then we can add those together. That gets us 102 over 70. And once again, we want to make sure we reduce. We've got an even number in the numerator and an even number in the denominator. So at the very least, we can divide these both by 2. And we will do just that to get 51 over 35. And that's our final answer. I'll just put it over here. See it a bit better. Okay. Any questions about that? Does everyone think that they got something like that when they did it yesterday? Okay, great. So moving on to number 7. This is a word problem now. So we've got 1/10 of a liter of paint to paint 1 meter cubed in a house. And we want to find out how much paint as a fraction would it take to paint 15 meters squared. So we've got 1 over 10. We can think about this as a ratio, because we've done ratios. So we can think of it as 1 over 10 to 1. So 1 over 10 liters, I'll put the units in, make it a bit more clear. So 1 over 10 liters has a ratio to 1 meter cubed. So we need to find how much paint, so our variable x in this case, what is going to form that equivalent ratio to make x to, how much paint do we need to make this equivalent ratio hold true? So make sure that these two ratios are equivalent. Well, we can think about multiplying 1 over 10 by 15. So we can think about saying, one way you can do it is by throwing them into fraction form. So that's 1 over 10 liters to 1 meter squared is equal to x over 15 meters squared. Okay, so you can set these equivalent ratios to be equal to each other. So then that means that x, if we multiply both sides by 15, x is going to be equal to 15 times 1 over 10. And you can put it in the divide by 1 if you want, but it doesn't really change anything. Okay, so then if we do that, that's 15 over 1 times 1 over 10. It's going to be equal to 15 tenths. And then that can obviously reduce. They're both multiples of 5, so if we divide each by 5, we get 3 over 2. So we can say, therefore, 3 over 2, 3 halves liters of paint is needed. If you want, you can also put it as 1.5 liters, if that makes more sense to you. But that's the idea. And to be completely correct here, we probably want a let statement. So we'll say let x represent the amount of paint needed. Okay. Oh. I don't want that anymore. Okay. Any questions there? Awesome. And then the last question has to do with limits. So we want to find the limit of this sequence below as the number of terms tends to infinity. So this is a pretty simple one. We've got 0.6, then 0.66, 0.666. And you know that in the end, it's going to go to 0.6 repeating. Okay, so 0.6 with 6's repeating on forever. And then that's the same thing as a fraction. So what fraction is this equivalent to? 0.6 repeating. Yeah? Sorry, did you want to say? 2/3. 2/3, exactly. 2/3. So 2 divided by 3 gets you 0.6 repeating. So we can say, therefore, the limit as n, which is the number of terms, goes to infinity, is 2/3. Okay. Any questions about any of that? Good. So did you find that easier or harder than the first formative? Hands up if you found that easier than the first formative. How about if you found it harder than the first formative? A couple people? And how many people found it about the same level of difficulty? Okay, well that's good to hear. Want to make sure that we're not doing anything super hard or super